Hey, this is Bob from INSYDIUM. In part 2 of our particle vorticity tutorial, we'll take our particles into Redshift and generate a custom material using particle data for coloration. We'll also have a look in After Effects at some retiming techniques. Here we are in our scene where we left it from video 1 then, and we've got our foam particles in our viewport here. Let's just have a quick look at the scene though. All of our Nexus tools are switched off because we're just reading this from cache. Our 2 water particles, they're switched off. We don't need those. We're just looking at our foam particles here. And we've got almost 4 million at the heaviest part in this scene. But in our emitter foam display tab, we've got the level of detail here set to 15%, just so it's not having to draw all of those 4 million particles. Right. What I need to do is just show you, we need to be aware of a couple of very important project settings here before we start. Let's hit Control D to get our Cinema 4D project settings. And in the project tab, if we go to the time, remember in part 1, we changed the default frames per second from 30, the default, to, we doubled that. And we simulated this at 60 frames per second, and that's so we can do some, if we need to, some slow motion effects in compositing, and we can play this at half speed and it'll be perfectly smooth. So let's just double check that our render settings are set to 60 frames per second as well, because we don't want to end up doing a long render and then realize that we've done it at the wrong frame rate. So yeah, look, frame rate 60, that's fine. Excellent, so that's okay. The other thing I wanted to show you in our project settings is the color management. Now we're in Cinema 4D 2025 here, and if we go to color management, the new default color space is ACES CG, and ACES CG as a color space, it works brilliantly for additive particles. This is perfect for us, but it's important to know which color space you've been working in, because then when you render it out, you need to, in your compositing software, whatever it is that you're using, Resolve or After Effects or whatever, you need to set that up to be in the correct color space as well. But we are using ACES CG in this scene. All right, so let's have a look at what we are going to render first. If I start rendering in my Redshift render view here, we've docked it in this part of our screen, you can see that it's just rendering the container. The reason it's rendering it, and we can see inside our container with our rocks down here, is that Redshift by default has a default light active. So even though I've got no lights in our scene, there is a default light, which I'm not a big fan of default lights in render engines. I like to think that you should place every single light in there yourself. So let's go to our render settings here. Let's go to the Redshift settings. And if we go to advanced globals, we can switch off this default light. We do that and hit play. Now we've got darkness. Now, some people like using the default light, that's fine. And it must be said that as soon as you put a Redshift light in your scene, even if you've got default light active in your settings, it's just overridden and it's ignored. It only works in the scene if there are no other Redshift lights in the scene. But we'll get rid of it. We don't need a default light. We're going to render our particles, and the particles are going to emit their own light. So how do we get that set up? Let's go to the emitter foam, tags, render tags, and bring in a Redshift object tag. Here we need to go to the particles tab, and we want the most efficient type of instance for our particles. And because we're not the tiny these, we don't need to see rotations or anything like that. We can just do a point instance, which is dead efficient. We'll leave the scale multiplier on 1 for now. This is going to be too big, but we'll just leave it as is for now. So now we've done that, we can set up a material to start rendering these particles. So let's go to our material manager, double click to make a new standard Redshift material, stick it on the emitter. Let's double click to open up the settings, and then in the standard node we need to make some changes. Now this is just going to be an emissive material emitting light, and as such we don't need any diffuse. Let's put that base color off. We don't need any reflection. Let's put that off. Don't need any transmission, no coat. The only thing we do need some emission. Let's put this on, say 5. And then we'll just leave that material at that for now. So if we hit render, now, even though there are no lights in the scene and we've switched off the default light, it's going to load in those particles, and look, they're all emitting light, but they're too big at the moment, as suspected. Also, for now, I don't want to see the inside of our container in the render, because it's creating this kind of diffuse lighting effect, which is going to put us off. We just want to look and concentrate on the particles. So let's just make the container invisible to the render. Yeah, okay, so now we're just looking at the particles, and they're obviously way too big. They're all overlapping and it's just a big white mess. So let's go to our Redshift object tag, and where we had that scale multiplier on the default one, let's put that down to maybe 0.05. And you're going to see here, once this loads in, it's going to look really cool straight away. Yeah, and look at all the detail coming through already. So doesn't that look cool? Excellent. So now what we want to do is put some color into these particles, and the color variation, we're going to use this black and white color data that we cached into our foam particles. Remember, the fast ones are white, slow ones are black. So let's open up our node editor, and we need to get that particle color into Redshift. So let's double click and we'll type in user. And what we want is this color user data node. This is how we access that particle color. Let's bring that in. Then if we come over to the settings, we need the right attribute name to get the particle color. So we can get that by just going onto the presets, particles, look, particle color. There we go. All right, so if I solo this, we'll see that particle color layer in our sim, and you'll see the dark ones you can hardly see. Yes, we're getting that color variation now. Very nice. So we want to use this to drive a colorful gradient. So let's double click, we'll type in ramp, and we want a ramp node, and we'll take the particle color as the input and then unsolo that. And now in our ramp node, let's just come down to the settings. You can create your own color gradient here, whatever you want. I'm going to load in a preset, and it is this, look, Vorticity 1. Let's double click that. All right, and what I'm going to do, I've got now, just looking at this gradient, we can leave it as is for now. I have a feeling we may get rid of some of these knots and space it out a little bit more, but that's maybe something that we'll look at when we make some tweaks. But if I hit solo now, you'll see that those color values have been mapped to this gradient now. So the white ones are this color, and the black particles are this color, and the grays are anything in between. Now we're not seeing an awful lot here, so actually once we set up our additive material, this will become much more obvious. And all we have to do that, let's unsolo our ramp. All we need to do that is to have this color ramp drive the opacity of the particles. And we do that with, look, it's already here, the geometry opacity setting in our standard material. If we come to the settings itself, that input is here, look, geometry opacity. This is what we're affecting. And we're putting our color into that opacity. And as soon as we do that, look what happens with our render. Now we're getting those additive particles with that color variation as well. That's looking pretty good. I think we could increase the amount of light that's been emitted now that we're rendering such small point instances. Let's go to our standard material, go back to that emission. Let's put this on, say, 10 for that weight. Yeah, that's brighten that up. That's looking very cool indeed. Okay. So that is the first step of our rendering. We've got our particles sorted. So now we want to start rendering the inside of the container as well. But we don't want, let's make it active again. We don't want it to have this kind of diffuse effect. We want actually some nice reflections, which is going to kind of trick the eye a little. So let's double click and make a new material. And this one we're going to put on our water container. Now this standard material has some reflections on by default, and yeah, look, already we're starting to see what this effect is going to look like, but we're going to make some changes. Let's double click that to bring up our nodes. So our standard node, we want to really darken this. We want it virtually black, which is going to make it very dark. Yeah, that's good. Now we're going to adjust the reflections. We don't want these reflections as rough. Where our particle, the reflections are very close to the particles, we want them almost to be perfectly crisp. So we can reduce the roughness, which adds detail back into those. So something like that's looking good. What we on? 0.086. That's looking nice. But what I want is to bring these reflections higher up our cylinder. So we can do that by adjusting the index of refraction. If we go really high on this, let's try 2.5. Yeah, look, so we're starting to get a little bit of reflections higher up. Let's go even higher. Let's go on 3. Yeah. So something like that, I think, is looking good. We can come back and adjust this later, but that, for me, is looking pretty nice. Okay, cool. So the only thing that we're not rendering at the moment is, well, rendering with the material, I should say, is our rocks. What's visible at the moment are our collision rocks, our low poly ones that we made to make the simulation efficient. We actually want to render the higher resolution rocks. So if we have a look in our object manager here, you can see we have this XP join with a collider tag on, and if we open that up, this is our low poly rocks. We don't want to render those. So let's make that invisible. There we go, invisible. So that is invisible from the render now. And actually, even without the rocks, it's quite a cool look, because you get this kind of negative space where the rocks were. But we want to render those high res rocks. So here are our rocks. Now these are in exactly the same shape and the same position. They've just much higher resolution and they've got more kind of deformation detail to them. So let's make these visible. And this is what we're going to render. So let's create a new material. We'll put this material on our null, which will actually automatically apply it to the rocks as well. And in that, we are going to, let's double click, and we're going to leave this pretty much default. The only thing we'll do is we'll make it more rough to make it kind of a very diffuse object. And let's put a little bit of color in the base. And we're going to go with a kind of a dark red that's not too saturated, maybe something like that. Okay, and that's going to do us. Alright, so I'm pretty pleased with that basic rendering setup, but we need to kind of get some cameras sorted. Let's have a look at our main camera. So I'll just stop rendering. We're going to bring in a Redshift camera. And this camera, we want it to be absolutely centered on our cylinder with no kind of angle, pitch variation or anything. Now, annoyingly, the scene that we inherited when we simulated our scene, if we go to the water container coordinates, it is not at world 0, which makes things difficult. So what we need to do is we need our camera to be at 0 relative to this water container. So to do that, let's just put our camera as a child of the water container. With the camera highlighted, go to the coordinates, and we'll zero out the X and the Z. And the heading will zero out. And the pitch, we want it looking directly down. It's almost looking directly down, but not quite. Directly would be -90. So let's put that on -90. Then let's look through the camera. And now we know we're looking absolutely perpendicular to the floor. And we can just use the camera's Y-axis now to dolly in or out. Now, in our original Beauty, we actually made this a very wide camera. So let's do that. In the Redshift camera object tab, we'll make the focal length 25, much wider. And then, as a result, let's go back to the coordinates and use that Y-axis to come in something like that. Okay, that's good. So if we just hit render now, it'll load that back in. And what we'll do is one last camera effect is we will add a little bit of depth of field, and the depth of field isn't really going to do anything to our hero portion of the frame, but it'll just blur out some of these higher reflections. So with our camera selected, let's go to the object tab, the optical tab is what we want, and the focal distance, let's get our picker here and we can click on this rock, and that's where we want to focus in on, and then the aperture we'll put down to say 1, and we'll switch on bokeh to get our depth of field, and we'll just let this re-render in our real-time preview, and that's just going to have blurred out some of these reflections near the top of our cylinder. Alright, so that is looking pretty cool. Let's just go to an earlier frame and let's have a look at what we're getting some really nice detail here. Let's go to frame 200 there or thereabouts. So this is looking really cool, and then we get this nice reflection here which will animate in a very interesting, cool way, and then that kind of blurs out as it gets nearer the top of the cylinder. So that is looking very neat indeed. I'm pleased with that. All right, so now that we've done that, what we need to do is start thinking about spitting out a render. And what we will do is go to our render settings, and we're going to go to Redshift. Now we're already put this into advanced mode, so we could look at our globals to switch off that default light. Now let's go to the sampling tab. Now what you're able to do in Redshift is you can set up everything manually, and the complexity of your scene often will drive the decision whether you need to go manual or whether you can just work with this automatic sampling that's a lot quicker and easier to set up. Now, because our scene is actually very simple, it's just got some reflection and some emissive particles, and that's it. There's no caustics here, there's no volumes, there's no kind of complex, transparent, translucent material, subsurface scattering, all of that stuff. So actually this scene is perfect to just stay in the automatic sampling mode, and we're going to get a really clean look, and it's going to automatically be quite efficient and be a relatively fast render. So all we are going to do is keep in automatic sampling, and we're going to look at this threshold. Now this threshold here is going to dictate how long your render is going to take, and it's a noise threshold. What it's saying is how much noise is allowed before I throw more samples at this to make it cleaner. How much noise is acceptable? So the lower this number, the longer the render is going to take, because a less amount of noise is acceptable before it throws way more samples at the render. So for example, let's just put this on 1, so considerably higher than the default. Let's render this current frame to the picture viewer to see how long it's going to take on this, and we're not going to adjust any other setting. So let's just go to my output tab. Yep, we want current frame. That's okay. All right, so let's just render to picture viewer. So here we go. So pretty quick to render. Look, 7 seconds. But here's the issue. At the parts that have depth of field, blurriness, and also blurry reflections, look how noisy and speckly this is. So this is not going to be acceptable. When this is animated, this is going to flicker and not look good at all. So we've got a really fast render time, not acceptable. So let's switch that picture viewer down. We'll go back to our Redshift render settings. So let's put this threshold on the default 0.01. And what you're going to find is that this is going to look really good and really clean, but it's going to take a massive amount of time to render in relation to our first test that was only 7 seconds. So already you can see the speed of that render is a lot slower, and it's especially going to be slower when it's got these blurry areas of reflections and shallow depth of field, and it's going to have to work hard to clean up that noise. But look, you can even see already, look how smooth it has made those blurry reflections with that, with all of those extra samples that it's used in this render. So we're coming through to the final few buckets here, and you can see we've got a really nice result. But you can, I mean, it's just obvious the difference in render time is astronomically greater, isn't it? So here we go, the last few partial buckets here, and that looks really nice, doesn't it? It's a really good render, but it took 57 seconds. And if we A/B, look, here's our high quality one, we go back to our low quality one, and it's looking really speckly, isn't it? Now, what I would advise you to do is to use and do a few tests with our render settings, a few tests with the threshold, until you got something that is giving you a decent look, but you've managed to get those render times down a bit. And once you've got something like that, I would urge you to render a few frames and play through those frames to see how it animates from frame to frame. You can't just look at one still and decide upon those as your render settings. You need to see whether there is noise, whether it's flickering, whether it's acceptable or not. I'm going to go one little bit higher than this to try and get these times down a bit. So we're going to go to 0.05 threshold here, and let's render to picture viewer. So we're going to put this one through. This one should be slightly quicker, and after we've done this, I'm going to show you one more trick, which is usually a surefire way of reducing your render times a little bit further. And we can already see how much faster that is. I'm not sure how much of this comes through with the compression of the video, but there's a little bit of noise in our blurred areas, but look, it only took 23 seconds. So that's interesting. Let's just go back to our render settings, and we're going to go with, let's go with 0.025, which is kind of a middle ground between the two. And this is going to be the last one I do, but obviously you spend longer getting to a point that you think is acceptable. Let's go to render to picture viewer. So this one should be better. And after we've done this one, I will promise I'll show you that other setting that can have a big impact on your render time. So let's have a look. Yeah, we've definitely got a smoother result in here, and I can see it's going to be quicker than our very high quality 57 seconds effort. So just coming to the final few partial buckets, and yeah, look, we're on 28 seconds now. So I'm saying, for me, this is good enough quality. I can live with this in the blurred areas, and we've got, look how much lower it is. It's you know, twice as quick as those defaults. Right, one last thing to show you. Let's go back to our render settings, and that is the bucket size. So if we go to our advanced, and then let's go to system tab, by default the bucket size is 128. Now what you choose here is a bit system dependent really, but if, like me, you have one very powerful graphics card, you're much better off placing this on the largest bucket size of 512. So with it on that, let's just re-render again. And you'll see that the buckets are much bigger as they come in. Here we go. Look at the size of this bucket. It's almost a quarter of the frame, and that's rendering through. And let's see if this makes a difference to our render times. It was 28 seconds with the standard bucket size, and we're just finishing up now. Yeah, so I mean, it's not night and day difference, but we've shaved off 4 seconds, and if that is 4 seconds per frame in a 600 to 800 frame sequence, those seconds add up. So for me, with my one very powerful graphics card, that is a good way to go. However, if you've got multiple graphics card in your system, it may be wiser to have a slightly smaller bucket size, because what you don't want is for all of your graphics cards to have finished their work and there just be one graphics card left working on the final bucket, and that bucket might take a minute and you've only got one graphics card working on it and the others are sitting idle. So obviously it's system dependent, you experiment, but adjusting that bucket size can make a really good difference to your render times. Okay, so I'm happy with that. We've got that down to 24 frames per second for a really nice clean render. That's looking great. So let's get this just set up for our final render then. We're going to go to render settings, we're going to go to output, we're going to render, well actually we'll click all frames, but then we don't need to render, our foam particles don't start appearing until frame 35, so let's just put 35 as that start frame. We're at 60 frames per second, which is what we want. Very good. So then I would urge you to go to your save folder. I'm not going to save mine, but this is the format that I prefer to go for. We want a high quality format, so we're going to use, I would always use OpenEXR as the format. Now just pull this down, and in this instance we can use this default compression method in blocks of 16 scan lines, but we can reduce the file size somewhat by using 16-bit floats. So let's just select that and we'll leave everything else as is, and then obviously you just put your file location and name here wherever you want to save these renders to, and that'll work. For me, I'm not going to save those out, just going to go to the output. Let's just confirm, yeah, everything is as it should be. Okay, very good. Let's switch that off and we'll go render to picture viewer. I'll carry on saving without rendering without my save. That's cool. Right, so there, the rendering's going. So what I'll do is I'll pause this here. We'll come back to you when it's finished and we'll have a look, see how long it took. So here we are in After Effects. That render's finished. It took just under 5 hours and we've got it here. So what I've done is I've opened After Effects in its default settings, and there's a couple of things we need to do to ensure that we've got our frame rate correct and also our color profile correct to match those ACES settings that we used in Cinema 4D. So we have our sequence here. First of all, let's go to the After Effects project settings. Let's click this button here. And we need to do a couple of things. By default, the color engine's set to OCIO color managed, which is what we want, but the configuration isn't right. By default, it's on ACES 1.2, but Cinema 4D by default has it set to ACES CG. So that's what we want to use. Let's click on ACES CG. And by doing that, look, it's changed this working space name. This is now called Scene Linear ACES CG, which is correct. That's what we want. And then the display color space is automatically set, and we can leave this. This is correct. It's set to sRGB, display ACES, SDR videos. This is how we set it. This is what it was set up in Cinema 4D. So by doing this, it means that when we're looking at our render in our viewport in After Effects, it will look identical to how it looked in both the Redshift render view and in the picture viewer in Cinema. So that's a really important step. This is all correct. Let's press OK. There's one last thing we need to do though. We need to make sure that our footage is being interpreted correctly, both for its frame rate and for the color space. So to do that, we right click, interpret footage, go to main. Let's do the frame rate first. Now, remember, we rendered and simulated this scene at 60 frames per second. And what we want to do is assume the frame rate. We want to interpret the frame rate as being 30 frames per second. And that means it'll get played back at half speed, which gives us the slow motion effect. So by default, my After Effects is set to 30 frames a second for sequences, and we want to leave it at this. If you wanted to play this in real time as it was simulated, you would change this to 60 frames per second, and then that's how it would play through. But we'll leave it at 30 for the slow-mo. Finally, let's just make sure that the color is being interpreted correctly. We'll go to the color tab here, and yeah, this is what we want. We want our media color space, look, working color space ACES CG. That matches what we had in our After Effects project settings. So that is absolutely correct. Let's hit OK. Now we can drag this onto this composition button to make a new composition. And if we have a look, this is going to look identical to how it looked in Redshift and in our Cinema 4D picture viewer. Excellent. And if we look, let's just go down to fit up to 100%. So we see the whole frame. That's looking really cool, isn't it? Very nice indeed. All right, so now that we have got that, what we want to do is a basic retime. And in fact, look, let's just hit space and we'll just cache this to the RAM. Now, these are obviously quite large EXR files, so it takes a bit of time to cache this to the RAM. But then once we've done that, we'll be able to play it in real time and have a look at it. So remember, we rendered 800 frames, but because we rendered them at 60 frames a second and we're playing them at half speed, we've actually got, look, 25 seconds worth of animation here. This is looking really, really nice. I especially like how it swirls and we get these currents in and around our rocks in the scene. Now, I can see a couple of things that I would change in my simulation settings, and it's more of a timings thing than anything else. Let's just have a look, though. You can see it playing through our initial splash. Then we get our rotator coming into effect, which starts rotating the particles around here. We get that nice acceleration, color changes, nice different currents. And here we get our secondary splash. Here it is. Now, the secondary splash for me isn't prominent enough, and this is what I would be changing if I was re-simming this. The rotator, I would get it to rotate up to full speed and then switch off the power of the rotator immediately, maybe at this point. So then the particles would rotate but settle more quickly. And then I'd want it to be settled to a much darker fluid before this secondary splash occurs. So this secondary splash, we really want it to be more prominent, and it would be more prominent if we didn't have as much of this fast moving glowing particles. So either it would have been useful to have had that splash happening later, or we switched off the power of that rotator earlier so it had time to settle before we got this secondary splash. But that's why it's important to do kind of, you know, test renders, test hardware renders before you kind of do your final kind of beauty, your final beauty pass. But for us, this is still looking really good, really happy with it. Let's just run through a technique of doing some very basic speed ramps here. So let's say that we want to have this nice slow motion effect, but only in certain parts where we've got nice areas of detail, like this swirling up here. So what we need to do is, with our layer selected, go to Layer, Time, Enable Time Remapping. And then in our time remap, what's happened is you can see our time remap here, and we have a keyframe at the beginning and the end of our sequence. Now what we need to do is identify where we want our first bit of slow motion. And I'm going to say I want the first bit of slow motion to start about here with these swirls. So what we'll do is add a keyframe, and here it is. Now what we need to do is we need to maintain this distance between these two keyframes, and that'll be real-time speed. But we want to shorten the distance here, which will ramp up the speed. So the way we do that is, look, we just select both of these last two keyframes, move them back, and now this relationship has remained unchanged, so that's just playing at real time, but these ones have been massively sped up. So now if we just put that in the RAM again, now we've got that quick start into slow motion. And in our first one, we can change the interpolation of this. This is just a linear keyframe. If we right click and do keyframe assistant, let's do easy ease out. and that's just going to smooth that off, and then we get this really nice bit of slow-mo. And obviously you can time these remaps to music, for example, if you've got a track, or sound effects. So we've got that. Now we want another ramp up before we get to this rotation. So maybe slow motion to there maybe, and then we want to ramp up to this slow motion bit. So we can add a keyframe there. So this is the part we want to be sped up. This bit we need to maintain the relationship to get that real-time speed. So let's select both, pull them back. The first keyframe, let's add an easy ease out. And then let's have a look at that. So we've got our slow motion, speeds up into our rotation. And then we want another speed up into our final burst. Yep, so maybe add a keyframe here. Add a keyframe to that burst. Maybe that. Let's get it so it's coming in. There's our splash. So this bit again, this is where I would prefer our splash particles here to be the only bright ones and for this to have calmed down. But we will work with what we've got. Let's hit our keyframe. We need to maintain the integrity of these two. Let's speed up those rotation ones. And our first, let's right click, keyframe assistant, easy ease out. Very cool. Yeah, that looks excellent. And then a final ramp up and then kind of fade to black is what we did. So let's add a keyframe, and on this one let's add a easy ease out, and we'll cut that off so it goes to black. We don't need it to stay on a freeze frame. So there we go, our speed ramp. Fade to black. Brilliant. I think that could actually be a bit quicker, couldn't it? It could really kind of whiz around. So something like that. So I've one last playthrough. But it's looking great. I'm really happy with the effect. It's looking really nice. And this is without doing any color correction or anything. Obviously you do what you want. Here's our final ramp up to black. That's looking excellent. Okay. So that is how we can get our rendered footage, get the color space correct, and then do some very simple time remapping. One last thing for me to show you is to make sure that when you render this out from After Effects, that you have it set up correctly and your render looks correct. There's one last gotcha that you've got to get right when we're doing this ACES workflow. So what we'll do is, look, let's go to our composition and add to render queue, which brings it to our render queue, and let's just go to our output module. By default it's set to H264, so we'll just leave it on this. But what we have to do is go to our color profile, and our output color space is not correct. We don't want to output this as ACES. We want to output this as our sRGB as we've been viewing it. So to do that, if you collect show all, and we want to output it to sRGB ACES SDR video, hit OK, and now you have done that. When you output your video and you play it back, you'll see that it will look identical in whatever player you're using. It will look identical to your After Effects viewport and your Redshift render view and the picture viewer. All of those images will look identical. So that is it. That's how we can take this really cool Vorticity sim, how we can render it out, bring it into After Effects and get that ACES workflow working correctly, and then spit out your final render.